Good afternoon, DKNOG. I'm Job Snijders. I work for NTT Communications, and it is a true delight to be here today. DKNOG is my second favorite NOG after NLNOG. This is a very objective opinion, of course. And it is unfortunate that many of you will never understand how delightfully comical the Danish language is to Dutch ears. Anyway. Today I want to talk about routing security. These are forward-looking statements. I want to share with you how the next 12 to 18 months will look, what kind of changes have already happened in the last 12 months, what the effects of those changes are, we'll go over some of the aspects and share what your role in this can be. Quick reminder, why are we doing any of this routing security stuff? Creating administrations and forcing people to administrate their routing intentions creates a trail of auditability. This can be useful to analyze incidents and criminal cases. But more importantly, bugs happen. There can be bugs in your automation toolkit. There can be bugs in your router's software. For instance, 2 years ago, NTT had a router that started ignoring its routing policy and was announcing routes that it should not announce. And this means that we rely on our peering partners to cover for us and filter out those invalid announcements. And last but not least, mistakes happen. The 4 and 5 are really close to each other on my keyboard, and a typo is quickly made, and such typos can negatively impact other people's business. So for these reasons, routing security is an important topic to keep the internet running. Unfortunately, routing security does not have the best public image. Many people consider it a dumpster fire. They'll say, there are so many holes in the ecosystem, it's not even worth plugging any of them because it's hopeless. But I disagree. I think there is a finite number of issues, and if we tackle those hurdles one by one, we'll end up with an internet ecosystem that is much, much stronger than where we are today. And a finite list of items means that we can just spend time and go through them one by one, which we'll do in this presentation. I identified a few gaps in the ecosystem, and I'll go through these one by one and explain what the mitigating strategy will be. People complain that IRR databases are inaccurate or don't apply validation. This can be solved. ISPs not filtering can be part of the issue, that there's no lack of path validation or the software quality of the tools that we have available. All these issues can be solved. I'll show you how. So what is the issue with IRRs? Last year, I spoke about what IRRs are, and I explained how IRR databases differ from each other, and that some of the IRR databases do not validate whether route object creation was actually consented to by the prefix owner. There are 11 IRRs that are not validating that are relevant: RIPE, NTTCon, RIDB, LTB, Arin, BBOI, Bill, Level 3, RGNet, TC, and Canary. And for these databases, there are essentially two types of solutions. There's something called a database lockdown, which is what RIPE did, and we'll talk about a different approach where we filter on the mirroring level. So what's the thing with RIPE? RIPE had a database where people thought that it was 100% accurate and with consent of the prefix holders, but it was a small minute detail that made that statement less true, namely that the RIPE managed space would be properly validated against the wishes of the owner. But if you would bring in, say, Arin or LACNIC or APNIC space, anybody could register anything. Fortunately, the database working group and RIPE community agreed that this was a security issue, and in the last 12 months, we have seen a successful execution of a project to resolve this issue. What happened? The RIPE database was split into two parts, RIPE and RIPE non-authoritative. The RIPE element can no longer, you can no longer create route objects in the RIPE database that are without consent of the owner. And with the right non-authoritative database, that's basically a frozen data set, you can only modify or delete objects, you cannot create new ones. If you click the URL, you can see more information about how this may affect you. But in other words, this means that RIPE's database, the security hole, has been closed, it's solved. Great, now there's only 10 IRRs left that need fixing. The Arin IRR is a whole different beast. In the Arin IRR, anybody can register anything. And here is an example of an IPv6 prefix that belongs to me, but was registered by somebody else. Fortunately, the Arin community agrees that this is a security issue as well, because if anybody can register anything in the Arin IRR, this means that anybody has an opportunity to create fraudulent route objects to sneak information into people's prefix filters. And the summary is kill it or improve it. The Arin organization is working on how to implement this philosophy, but I would argue that since the community agrees that this is an issue and Arin staff is investigating their options and setting out a timeline, we can chalk this off as almost solved. Great, only 9 IRRs left. You can kind of see where we're going with this. But at this stage, we need something like a bigger hammer, because not all of these IRRs are operating under the same definitions. Some of these are more volunteer-driven than others. Some of these have 24/7 staff supporting it. Some don't. We need something where we can solve all of these IRRs that are not validating in one go. And to this, I propose that we can use RPKI data to clean up the IRR. Let's zoom in on how the IRR system actually works. The IRR system, although it's tens of separate databases, access to those databases is predominantly done through 2 gateways or aggregators. Those are whois.radb.net and rr.ntt.net. And both these instances run software called IRRD. And what I propose here is that the hegemonic duopoly is used for the good of the internet, and I'll explain how that would work. You have all these IRR sources, like RIPE, APNIC, Arin, NTTCon, RDB, etc., and they are mirrored into these 2 instances at RDB and at NTT, and clients such as BGP Q3 or PEval or IR Toolset or IXP Manager use these 2 aggregators to fetch the information to generate filters. A client software that is generating filters generally does not connect to the original data source, but it connects to this aggregator. And we can use RPKI software to drown out conflicting IRR information. I think this can work because if we look at origin validation, the trick is that when you receive a BGP update, you match the prefix and the origin ASN against a table that you constructed based on RPKI data. This procedure is called origin validation, and based on that you end up with valid, invalid, or unknown state. But a route object has a lot of similarities to a BGP update. An IRR route object, too, has a prefix and an origin, and this means that we can apply the origin validation procedure to this type of data. And if we look at how that would be implemented in practice, it means that we can mirror unvalidated IRR sources into the aggregators if we apply this RPKI-based origin validation procedure at the mirroring level. And this means that clients that are querying RDB or entities' IRD instances will no longer receive IRR information that is in conflict with the published RPKI ROAS. So this is quite cool because it means that people do not need to update their tool set. They can just continue to generate the filters as they are today because we are upgrading the software in the middle. So this means that in one go we can positively affect hundreds of clients. Why does this work the way it works? If we look at how IRR and RPKI are different, While at face value they're very similar, both describe a prefix and an origin ASN, and you may intuitively think, what's the difference other than the cryptographic verification? IRR route objects have a different semantic than RPKI ROAS. And the difference is that an IRR route object only describes a possible state, but it makes no statement about other IRR objects or other sources of information. So if I have an IRR route object, it means that that origin ASN may announce that prefix, but it doesn't tell me anything about other data sources such as whois or BGP. And another aspect is there are so many IRR sources, nobody uses all the IRR sources. There's no coherent global view on this information. RPKI, on the other hand, the semantics of such objects are explicit in that it is an absolute source of truth. We have a cryptographic verification that the owner of the prefix was the one that created the ROA, and it drowns out or supersedes all other sources of possible truth. And what this means in practice is that IR information is good to apply on your eBGP sessions with your customers, but you cannot use it to filter out your upstream provider, because your upstream provider or the rest of the internet may be using IRR sources you are not aware of or don't have access to. RPKI, on the other hand, allows you to apply filters on each and every eBGP session, your upstreams, your peering partners, and your downstream customers. So RPKI data, because it's been purposefully positioned as the ultimate source of truth, can be applied on a wider range of eBGP sessions than IRR information. And this also means we can use this information to filter out on the IRR database level. There are two major advantages to using RPKI data to drown out conflicting IR information. One is that it provides an industry standard mechanism to clean up 20 years of craft. If you look at the IRR system, there were always incentives to add information to it, but there were never incentives to remove or clean up the information. And if we look at IPv4 internet, it has a long history. There could be objects that were created 20 years ago, but meanwhile the company went out of business, the IP space got reassigned to a different organization. That different organization may not even be aware that there are still route objects from the previous owner, and they may have trouble cleaning those objects up. But if we use RPKI, we can tell people, if you create ROAS, it will automatically, in all the IRRs that support this feature, either suppress or delete conflicting information. And this means we no longer have to manually email around to get objects cleaned up. So that is a positive benefit that affects the past and helps us clean up our legacy. What it also does, it prevents IRR-based hijacks going forward. Because the moment you create a ROA and the moment this feature is active, if people try and submit a route object to one of the databases, and the submitted route object is in conflict with an RPKI ROA that was already published, the creation of that route object will be rejected. So it cleans up the past and it protects you going forward. And I think this is an incredible advantage to RPKI that adds value compared to only BGP origin validation. So with that, I would argue that the issue of non-validating IRRs for all practical intents and purposes is resolved. Software that will have this feature has been created on GitHub. It's sponsored by NTT and executed by a company called Dashcare. It's open source in the spirit of the original IRD releases. And if you have an IRD instance in your network that you use to generate filters, please consider upgrading to the latest version of IRD and help us improve the quality of this software. Now, onwards to IXPs. For years, the mantra at IXPs was that filtering at route servers is really hard. Fortunately, I would argue that that no longer is the case. On peering.exposed, we're keeping track of which internet exchanges have secure route servers and which don't. And if we analyze that data, we can see that if you look at the top 10 largest internet exchanges, 9 out of the 10 have good filtering in place. And if the largest ISPs can do it, that also means that everybody can do it. Other good news is that there is excellent open source software out there to generate route server configurations, namely a route server and ISP manager. And ISP Manager recently added support for RPKI in version 5. A route server already had support. So RPKI at Internet Exchanges is easy if you stick to either one of these high-quality open source projects. Now, another aspect about RPKI, and this may come across as a somewhat controversial statement, but I would go as far as saying not everybody needs to do origin validation. If we look at how the internet ecosystem is constructed these days, we have seen a tremendous amount of consolidation and with consolidation I mean that people used to run their own ISP, have their own ASN and their own prefixes and servers to run their website. But nowadays many people move the hosting into the cloud, and cloud is provided by select few companies. In other words, a lot of things relevant for end users are happening in a relatively small amount of companies. While there are downsides to this extreme consolidation of internet services, the one upside is that it means that only a handful of companies need to make a move for there to be significant global impact. In this instance, the link at the bottom describes the famous BGP hijack that occurred last year where some cryptocurrency got stolen. The negative effects would have been largely mitigated if just 2 of these cloud providers were doing origin validation for each other's ROAS. That would have created secure paths back and forth, and the hijack would have been far less effective in its reach. This brings me to another important topic. Many people, myself included, originally thought that RPKI origin validation is worthless without path validation. And in theory, you're right. However, in practice, there are some interesting phenomena on how the internet works that perhaps reduce the need for formal path validation. If we look at how the internet is constructed, and this is a graph that spans a bit more than 10 years, it plots out the average AS path length as observed from some ripe risk collectors. And we can see that the average AS path is relatively stable over the years, despite the internet default free zone growing quite steeply every year. At the beginning of this graph, there were perhaps 25,000 ASNs in the default free zone. Today, that's 67,000 ASNs. And despite the number of ASNs in the default free zone growing, the AS path length remains relatively stable. And this means that people connect directly with each other. We keep looking out for each other. We keep connecting to internet exchanges, set up private peering, because it's cheaper to cut out the middleman. Peering is excellent. So this economic driver that has held the internet together as a relatively densely connected graph brings some interesting benefits if you combine it with origin validation. Let's go over a scenario. A provider, Google, announces a /23. They use intermediate providers to reach a subset of the internet. And on the far side, we have Cloudflare that is receiving that route announcement. And in the lower left bottom, we see a few announcements and their respective AS paths. So despite there being multiple paths, the attacker that announced the /24 is winning the traffic, which means they can insert themselves between Google and Cloudflare in this example, even though the AS path is longer, because more specific always wins with routing. All right. In a direct peering scenario, for instance, if we cut out the middleman, but this same attack happens in, say, an internet exchange where the attacker and Google both peer with Cloudflare, the /23 will lose from the /24 because more specific wins. Now, let's throw RPKI into this. Google created an RPKI ROA for this /23. The maximum length indicates that only a /23 is a valid prefix length for this specific prefix, and that the only origin ASN that is authorized to announce this prefix is Google's ASN. If Cloudflare were to apply origin validation on its eBGP sessions with a invalid is reject policy, you can see that the /23 is winning again, despite it being less specific, because the RPKI ROA indicates that the /24 more specific is invalid and should be rejected. All right. Then the attacker wises up. They say, fine, we will announce a /23 as well. But that doesn't work, because despite the prefix length now being compliant with the ROA, the origin ASN is still not compliant with the ROA, so Cloudflare will be rejecting this attacker's prefix. Then the attacker continues to wisen up, and they think, okay, we'll spoof the origin ASN. So from a BGP perspective, this means that behind the attacker's ASN, they will falsely insert Google's ASN, and this means that the announcement is both a /23 and it's originated by Google's ASN. So for all intents and purposes, it's no longer an RPKI invalid announcement. However, its AS path is now longer, because to spoof an AS, you are adding the AS to the end of your path. And because there is direct connectivity between these providers, and shortest AS path often wins, specifically if you're comparing multiple peering partners amongst each other, the attack is still not effective, now not because of RPKI, but because the shorter AS path. So this means that as we continue to grow the internet, as we continue to directly peer with each other, if we add RPKI origin validation, we have a very strong, robust system against misconfigurations or malicious BGP hijacks because of the way the internet works. So keep peering and do RPKI. Then lastly, for a number of years, there was a concern that there was no healthy ecosystem surrounding RPKI. But in recent months, or in the last year, this has dramatically changed with the arrival of new RPKI route cache validators, such as NLNet Labs Routinator. OpenBSD is also working on an RPKI validation implementation. And this means that on the validation side, we now have multiple choices. And for a healthy ecosystem to exist, for two excellent choices to exist, we need 3, 4, or 5 implementations competing with each other. If I go to my management and I say, hey, let's do RPKI, but we'll be dependent on one vendor, they will be more reluctant than when I say, you know, I prefer this vendor today, but if for whatever reason the quality of this vendor software starts to degrade, for instance, if they run out of funding, there are other excellent choices that we have available to us. And the fact that we have multiple choices increases our resilience in that regard. If you look at the serious routing vendors, Cisco, Nokia, Bird, all of them had origin validation implementations for a while now. And they're basically just waiting for people to start using it. Software cannot improve in a vacuum. I think we are now at the point where vendors have done their job, they have created implementations, and it is now up to us operators to use this software to drive it to perfection. This means that, yes, we may find some bugs in the wild. Yes, there will be some incidents, but it is up to us to start deploying this software, because otherwise it cannot further improve. And it also means that there's very little, there's virtually no excuse anymore to not do this, because the software is available to you. I wanted to mention a tool called PMACT. Some of you may know this tool and maybe are already using it in your networks to analyze traffic flowing through your network. What PMACT does is it can consume BGP feeds, it can consume SFlow, NetFlow, IPFix, you name it, and it can correlate these data sets and provides you with aggregated data that shows how much traffic is flowing from what type of customer to what type of peer, or how much traffic is flowing from your upstreams to which specific customers, which continents. It's very powerful analysis software. And what we have done in PMACT is we've added the capability to do origin validation in the traffic analysis engine of PMACT. And this means that you can now model what the influence will be on your network when you deploy RPKI origin validation. Because if you deploy filters, any type of filter, you'll want to know how will this affect my network? Will I lose revenue? Will I lose a lot of the traffic that is flowing through my network? These are important questions that need answers before you can properly consider deployment. So to that effect, PMACT will ingest ROA information from a validator. It will mark announcements as they come in, and it provides this data in the aggregation step. And it allows you to differentiate between BGP announcements that are invalid but covered by a valid or unknown, less specific announcement. In other words, if you drop those announcements, you still have a path towards the destination. And it differentiates RPKI invalid announcements that have no alternative path. And those are the only ones that are relevant because those are the ones where you may lose a path towards that set of IP addresses. We deployed this in NTT's network to analyze what traffic currently looks like in our global backbone. And the colors show blue is traffic flowing towards unknown IP prefixes. Orange is traffic flowing through RPKI valid announcements. So this means that a substantial set of the traffic flowing through our backbone is covered with RPKI ROAS. This is good information because it means it's a relevant technology. And then we see a sliver of pinkish color. Those are RPKI invalid announcements that are covered by less specific unknown or valid announcements. So this means that if we would apply a invalid is reject policy, we will still be sending traffic towards those destinations. And then the top green sliver, which in the graph should represent something like 0.000 something percentage of traffic, is traffic that would disappear if we deploy this policy. And this, to me, means that we can safely move forward with origin validation because there is no measurable revenue impact because the amount of traffic going to those announcements is almost unmeasurable. It's statistically insignificant. And I've heard similar reports from AT&T that the amount of traffic they lost when they turned on RPKI origin validation was barely or not even measurable. So this is good news. I want to ask you, if you're an ISP, please make sure you're creating ROAS. If you create ROAS, even if you're not doing origin validation yourself on your BGP borders, your ROAS will help protect you in the IR ecosystem, may even help clean up still routing information, and it allows other people to protect your interest through route servers or through actual origin validation implementations in ISPs. If you're an internet exchange, you can start doing origin validation now. The software is out there, BERT, OpenBGPD, FRR, whatever your pick of poison is, they have support for origin validation. The configuration generators have support for RPKI. So it's really just a matter of committing yourself to sit down for an afternoon and enable it rather than it being a big engineering project. Later in 2019, we'll start to see RPKI being used to clean up IR information when this feature becomes available in IRD4. And I also hope that later this year, the Arin RPKI TAL situation will improve. For those of you that are not aware what this problematic situation is, in RPKI, you have a number of root certificates or public keys. And the word public in public key kind of implies that you'll want to make the key publicly available and distribute it as wide as possible. However, the litigious nature of this American organization drove them in a slightly different direction, and they thought it was an excellent idea to lock up this public key behind a legal agreement. This legal agreement prevents the RPKI cache validators from shipping with the RPKI tile from Arin by default. So this means that if you install an RPKI software, it will have 4 out of the 5 public keys. And this is problematic because we have already seen that many ISPs install the software, do not read the documentation, and fail to install the 5th missing key. Or they maybe disagree with the legal agreement, and for that reason will not be installing that Arin key. And this is measurable. About 20% of ISPs doing origin validation are not using the Arin tile, which means that the American IP space is far less protected than, for instance, RIPE covered space. But I hope that this will improve over time. Some deployment highlights. A very famous example is Cloudflare, who fully committed themselves to use RPKI origin validation across their CDN product. And this means that if you peer with them and you create ROAS, they will honor those ROAS, and that will make it much harder for attackers to insert themselves between the CDN and your own ISP network. YYCIX was one of the first North American internet exchanges to deploy origin validation. But the good news doesn't stop there. A few weeks ago, AT&T, one of the North America's largest carriers, started dropping RPKI invalids on their peering edge. And with such a big name doing origin validation, it shows that RPKI is actually useful and considered serious in the real world. A Nordic example, Nordinet is deploying origin validation. They're rejecting invalids all across their eBGP edge. KPN is rejecting them on their customers and will slowly move that out towards all their peering sessions. African operators of significance, Seacom and Work Online, committed to deploy origin validation in early April. And there's a string of internet exchanges that does origin validation as well. And NetNot committed to deploy origin validation quite soon. So this means that a lot of companies and organizations are deploying origin validation, and that if you do too, you'll find yourself in good company. So with that, I want to end this presentation on a positive note. I think routing security in the months to come will see significant increases and that the overall internet security posture will be much stronger than it was, say, 2 years ago. We have a real shot at making the internet much more reliable, much more robust through these various initiatives, and you too can do your part to make it so. This brings me to the end of my presentation, and with that I would like to open up the floor for comments, suggestions, rotten tomatoes, or whatever you can share with me.
Hi, y'all. I'm Jerry, NLEX. I'd just like to add 2 things to your presentation, which was actually very good, thank you. NLEX has been doing filtering for about a year now on both RPKI and IRR. We have had a large political discussion internally on what the impact would be. Actually, that discussion internally took more effort than the actual impact on the traffic. We've seen none. So don't be afraid, start filtering. The other thing I'd like to say is that although the internet ISPs get a lot of attention on filtering on the route servers, be aware that we only control what actually happens on the route server. None of your traffic on your bilateral sessions we can see, we can alter, we can help you with. That's really all up to you. Sometimes that's still a bit of an open point, but for other people, that needs to be stressed.
Yeah, no, that's excellent feedback. I should update my slide and add your company name to the list of deployers. It's right. The route servers are a convenience service, and it is interesting if you're less inclined to set up many BGP sessions because you don't want to spend the manpower on it. With the rise of secure route servers, you now actually have a very valuable alternative to bilateral sessions and can enjoy the benefits of proper filtering. But if you don't use them, you should take care to deploy origin validation in your own network. Other questions, comments?
Hello, hi, I'm Thilo from Global Connect. Why do we need IRR at all?
Why do we need IRR?
Or is this just a stopgap?
It's a very good question, because you can see that there's a lot of similarity between IRR and RPKI, and we argue that RPKI is a better source of truth. I think the challenge we have is that we're in a transition from one technology to another technology. IRR was the de facto standard to administrate your routing intentions, and RPKI is becoming that standard, but we're not there yet. There's millions of IRR objects, but there's less than 100,000 RPKI objects. So it will take the industry time to create ROAS. Another aspect that should be considered is that RPKI, even though it's globally available through the 5 RARs, not all IP space is managed through RARs, and they may not have access to RPKI services. In the RIPE region, if you have legacy space, you can sign an agreement with RIPE that gives you RPKI services, but doesn't indicate anything about ownership. So that's a very smart approach. In the Arin region, you kind of need to hand over your legacy space to Arin and then get it back assigned from them. And the ownership issues are more complicated. And then there is the matter that some national internet registries, so for instance, you have the Korean NIR, APNIC supports RPKI. They delegate space to the Korean National Internet Registry, but they don't support RPKI. So this means that Korean operators cannot create ROAS. They can do origin validation, and I hope they will do so, but it's, the ecosystem has covered the majority, maybe 95%, but not all. And there will never be a flag day where we say, oh, we turn off IRR and we continue with RPKI. This is why I think the IRD software enhancement that is coming is relevant, because we'll be in like a 10-year migrational state where both systems coexist. And if we can add value to the newer technology by using that data to clean up the older technology, I think we have a very workable situation where they are not disrupting each other in any way or form. So for this reason, IRR is relevant. It will lose relevance over the years to come, is my expectation, but that's a multi-year process.
Hi, Martin from Fibia. You said create ROAS. Wouldn't it be a lot easier if the 5 RARs went out and automatically created them for you once you create a route object, or at least for authoritative space like the RIPE authoritative database?
Well, the RARs cannot really know your routing intentions. They don't know if you have a backup provider, if you're going to switch providers. All they know is that they gave you the space, but you are the operator of the network. You know where you're going to announce it, what the prefix lengths will be, if you're going to chop up your space into /24s or announce it as an aggregate. So RIPE has made a lot of improvements over the last years to enhance the web UI, where it makes decent suggestions about what you should create. But fully automated ROA creation by the RARs will do more damage than good, I think, because I'm a firm believer that the owner of the prefix should be the one that dictates what should happen with a route announcement. And any other party is simply not in a position to make such statements. They can at best guess, and at worst they'll guess wrong. I believe RIPE is looking into streamlining the process of creating route objects where they'll make suggestions that you also create RPKI ROAS and vice versa. But these enhancements are being considered. So the best we can do is make the process as easy as possible, and I think RIPE has done a phenomenal job in that regard, but they'll never be in a position to actually make the statements themselves. No more questions? Well, if you need help deploying RPKI in your network, feel free to reach out to me. My email address was on the first slide. I don't care if you're a competitor, a partner, or a customer. I'm happy to help you in that regard. Thank you for your time.